So today we're going to be looking at applications of polynomial equations and polynomial inequalities. So example 1 here, we have an open-topped box that is formed by cutting squares out of the corners of a 30 centimeter by 50 centimeter piece of cardboard, then folding up the sides. What size of square cutout will allow for the creation of a box with a volume of 4,000 centimeters cubed? Round your final answer to the nearest tenth if necessary. Okay, so we have this piece of cardboard here. They've removed a little square from each corner, and then they folded up those sides to create this open-topped box. And we're trying to figure out, what does the size of that square that they cut out need to be? So that's what we're going to declare our variable to be. We are going to let x represent the length of the square that we cut out in centimeters. Now in the question they give us the information about volume. Okay, so we know that 4,000 centimeters cubed is going to be our volume. Remember, volume for a box, rectangular prism really, is going to be length times width times height. So we need to figure out an expression in terms of x for length, for width, and for height. Okay, we need to write it all in terms of x because we only know how to solve when there's two variables, and right now we have 4 variables. So if we look at this box here, the top all the way along is 50 centimeters, but we are taking away x from each side. So we had 50 centimeters, but we've taken away 2 x's. So the base of this box, all the way along here, is 50 minus 2x. On the other side here, it's usually 30 centimeters, but once again, we've removed x from each side. So the length of that side is going to be 30 minus 2x. And that ends up being the width of the box once we've folded up the sides. And then last but not least, when we fold up the sides, that length right there, that x, actually becomes the height of the box. And if you can't visualize this, you can always take a piece of paper out at home, cut out little corners out of all 4 sides, and then fold up the sides to make a box. And then you'll be able to see how it relates. Okay, but now we have a length, a width, and a height, all in terms of x. So we can sub that into our equation here. Okay, and I'm also going to plug in the 4,000 for v. So my length was 50 minus 2x. My width was 30 minus 2x. And my height was just x. Now, we are trying to solve for x in this equation. In order to solve for x, we need everything over on one side and fully factored. So to do that, we're actually going to have to expand everything, move the 4,000 over, and then refactor our equation. So let's start by expanding. So I'm going to expand these 2 brackets first using FOIL, and that will give me 1,500 minus 100x minus 60x plus 4x squared, and then I still have that x being multiplied on the end that I haven't done anything with. Okay, now I can just multiply that x in. So I would get 1,500x minus 160x squared plus 4x cubed. And then moving everything over to one side, so moving that 4,000 over, and putting everything in decreasing order of power, we're going to start with 4x cubed minus 160x squared plus 1500x minus 4,000. And now it becomes exactly like one of your solving equation questions. We have a polynomial, it's equal to 0. We now need to factor this. Okay, first thing we should always do is look for a common factor. And in this case, there is a common factor of 4 in everything. So I'm going to pull out a 4 first. Okay. And now I have a cubic that needs to be factored. Okay, you can check to see if you're able to group it, which in this case you're not. So we will need to do factor theorem and synthetic division to factor this polynomial. So I'm going to let that polynomial be f at x, and now we're going to have to start by finding what you can plug in to make this function 0. Okay. Remember, the factor that you're going to be able to plug in is going to be a factor of 1,000. So start with plus or minus 1, and then keep going until you find a number. I'll give you a hint. 5 works. So f at 5 equals 0. Therefore, x minus 5 is a factor. Okay. Because x is a side length, we had a pretty good idea that the number that we were going to plug in was going to be positive, because we can only have positive side lengths. But it may also sometimes end up being negative, but most of the time it's going to be positive. So I'm going to divide out my factor of x minus 5. So pull down the 1, multiply by 5, add, multiply by 5, add, multiply by 5, and add. Okay, so this is sort of a little off to the aside there where we actually factored it. And now if we put that all back into our equation, the 4 is still outside, and this f at x has factored into x minus 5 times a 1x squared minus 35x plus 200. So we can't solve this quadratic by factoring. You're going to need to use quadratic formula. But we are at the point now where we can solve this equation. One answer that we get is x equals 5. We do still need to solve this second one. Okay, so we're setting it equal to 0 to solve it, which means we can use the quadratic formula. So x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. And we get that this is 35 plus or minus the square root of 425 over 2. And if on your calculator you split that up into the plus and minus, you will get x equals 27.8 and x equals 7.2. So we have 3 possible solutions, and it might end up that you do have more than one solution that works, because it is possible sometimes to create more than one box that has the same volume inside of it. So we do need to check to see if all of these are valid answers. So what you're going to do is imagine plugging the numbers in for the length, width, and height, and make sure that you're not getting a negative length, width, or height. So the 5 would definitely work. If you try plugging that in, it works in all of them. The 7.2 will also work. But if you plug x equals 27.8 in for our width, right, 30 minus 2x, if you plug that in for x, you actually get a negative answer. So this one is inadmissible. It's not a valid answer. It would give us something that doesn't make sense in terms of the word problem. So we have two possible answers here. The box cutout can have a length of 5 centimeters or 7.2 centimeters. Example 2 says the value V in dollars per share of a new stock T weeks after the stock is first issued is given by this function V. According to the relation above, when will the value of the stock be greater than or equal to $12 a share? So they're talking about greater than or equal to, so that means they're talking about an inequality. So we want the value to be greater than or equal to $12 a share, so that means that t cubed minus 9t squared plus 20t has to be greater than or equal to 12. Okay, we're going to move that 12 over to the other side, because remember we always want the other side to be 0. Okay. And take a minute, pause the video, and factor this. Okay, so you should have gotten that 1 worked. So dividing out t minus 1, and you would get that our function here, which I called f at t, factors into t minus 1, t squared minus 8t plus 12 is greater than or equal to 0. And that's a nice quadratic that we can factor now. It will factor into t minus 6 and t minus 2. And this equation would have had roots of t equals 1, 6, and 2. So those are going to be our boundaries for either our sign line or our chart, whichever method you like using. So here I've drawn out a sign line, and we are going to check each of these test values in our function there. So plugging in a 0.5, I would get negative, 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 which means my overall answer would be negative. Plugging in a 1.5 to each of these brackets, I would get positive, negative, negative. So I would have a positive answer. Plugging in a 3, I would get positive, negative, positive. So I'd get a negative answer. And then plugging in a 7, I would get all 3 being positive. Okay. And because we want the answer to be greater than 0, we're going to take the 2 positive regions. Okay. So now we just need to write out a therefore statement. So the stock price would be greater than or equal to $12 from week 1 to week 2, and from week 6 beyond. Okay. A little note, it is a real-world problem. So this sign line actually does have a boundary here at 0 because time can't be less than 0. But because we didn't actually end up using that section at all, it just didn't come into play in this question. Okay, so you guys have some homework questions to do, and if you have any questions, please email your teacher.